Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem of quantum mechanics. Problem having been chosen from the book Quantum Mechanics Concepts and Applications by Nordine Zetley. Okay, as usual, we first come to its statement. Its statement has two parts. Okay, part A: estimate the energy of the electrons that we need to use in an electron microscope to resolve a separation of 0.27 nanometer. Nano standing for 10 raised to the power minus 9. In a scattering of 2 electron volt protons from a crystal, the fifth means n equal to 5. The fifth maximum of the intensity is observed at an angle of 30 degree. This is angle of Bragg's relation. Okay, estimate the crystal's planar separation. Okay, we have solved similar several problems in our previous videos, in which we had chosen the book of Kenneth S. Crane, Modern Physics. Okay, but now we are following Quantum Mechanics by Nordine Zetley. Okay, so we come towards the solution, and first we try to develop a foundation regarding the understanding of this problem. Okay, we know that each material particle of momentum p behaves as a group of waves, matter waves, whose wavelength lambda and wave vector k are given as lambda equal to h over p and k equal to p over h cut, where h cut is equal to h over 2 pi. Okay, h cut is called h reduced, where h is the Planck's constant. Okay, h cut or h reduced is equal to Planck's constant h divided by 2 pi. This is known as the de Broglie relation, which connects the momentum of a particle with the wavelength and wave vector of the wave corresponding to this particle. Okay, we have just developed a foundation to have some origin regarding the solution of this problem. Okay, so this is a valid foundation. Now we move forward. Part A. Okay, that foundation was we can say common for both parts. Okay, part A: let E be the kinetic energy of the electron, and me, where E is written as a subscript of M, be the mass of the electron. Then, because kinetic energy is equal to half m square, so here in place of K we are using E, so E is equal to half MeV square. Okay, here in place of V we can use this expression P over Me. Okay, because momentum is equal to mass into velocity, P is equal to Me into V. Okay, so we can V in this form. Okay, by converting V in this form, one Me will be cancelled with this, and we will get kinetic energy of electron equal to P square over 2Me. P square over 2Me. P square E is equal to P square over 2Me. Here again we have used P equal to h over lambda. Okay, P equal to h over lambda, h square over lambda square. Okay, in the next step what we have done, we have multiplied and divided by c square. Okay, in this way expression will have no effect. Okay, multiplied and divided by c square. In this way the denominator will take this form, hc square over 2mec square lambda square. Okay, dear students, here this value mec square has a constant value from a table, and similarly this Planck's constant into speed of light has also a fixed value according to a table. Now we move to that table and see what is the value of this hc and what is the value of this mec square. Okay, so we are moving towards that table. Okay, yes, this is the table. This is the table. Here me is equal to 0.511 million electron volt over c square. Mass of proton is equal to 938.3 million electron volt over c square. And combined value of hc is equal to 1240 electron volt nanometer. It can also be written as million electron volt into femtometer, but we will take this first value. Okay, moreover, which value? H Planck's constant in terms of joule second and in terms of electron volt into second, we will take this second value, 4.136 into 10 raised to the power minus 15. Okay, so we move back. Okay, yes, here is this question. Here in place of hc we have used this value, 1240 electron volt nanometer. In place of mec square we have used this value, 0.511 million electron volt. Okay, actually dear students, this value is mev over c square. Okay, here we see that here 0.11 mev over c square, and hence c square will be cancelled with the c square. Okay, and hence moreover, value of lambda is given in the statement which is 0.27 nanometer. Nano standing for 10 raised to the power minus 9. This nano again also, but we do not need to put value of nano because nanometer square will be cancelled with nanometer square. This will be electron volt square and this is electron volt. Okay, 1 electron volt will be cancelled from electron volt square, and hence in short, after simplification we will get kinetic energy of electron E equal to 20.63 electron volt. Okay, moreover we see whether we have used any other conversion factor or not. I think it is just simplification, no other except here in place of m we have used 10 raised to the power 6. Okay, and nanometer square will be cancelled out with the nanometer square. Okay, no point to be discussed. Okay, just simplification, and hence we get the result. Okay, now we come towards part B, in which proton is under consideration. Okay, in part A we had taken kinetic energy E for electron, but here is proton, so we take E dash. Okay, let E dash be the kinetic energy of the, sorry, this is a minor mistake. Okay, let E dash be the kinetic energy of the proton. Okay, sorry, actually in typing these video lectures in math type software, an effort is always made to avail the facility of copy paste. Okay, because this is very similar to part A, so that portion was copied pasted in math type for B part. Okay, so here this is not electron, this is proton. Okay, actually electron was for part A, but here in part B, in place of E dash is being used. Okay, and in place of electron, proton is under consideration, and in place of MP is under consideration. Okay, let E dash be the kinetic energy of the proton, and MP, where P is written as a substitute of M, be the mass of the proton, then E dash is equal to half MP V square, and so on, exact same as in previous part. Okay, now dear students, here one thing more is being used, that is Bragg's law. Okay, here we have stopped our process and we have given it equation number 1. Next, what we will done, we will use the value of lambda from Bragg's law. Okay, Now we move to end of this problem. Here a Bragg's equation, Bragg's relation is given. Okay, Bragg's condition for constructive interference for an array. Okay, distance between adjacent rows in array 2d sin theta, where d is the distance between adjacent rows in array and theta is the angle of line from surface of array to mth bright region on screen. Okay, is equal to m lambda, where lambda is equal to wavelength and m is equal to 1, 2, 3 and so on. Okay, so we have used in the next part of this problem we will use this value. Okay, in place of lambda we will use the value of lambda from Bragg's law. Okay, so using Bragg's relation, that is lambda equal to 2d over n sine phi. Okay, there is one Greek alphabet is psi and one is phi. I think it is phi. Okay, anyhow we may confirm it if we need. Okay, lambda equal to 2d over n sine phi, where d is the crystal planar separation. Using Bragg's relation in equation number 1, we get E dash is equal to x square over 2 mp into n square over 4 d square sine square phi. This implies that from here we keep value of d square on one side and all other values on the other side of equality. Okay, so d square will become equal to d square equal to n square h square over e dash into 8 mp sine square phi. Okay, we have designated this expression as equation number 2. Okay, using in this expression we will use these values. Okay, n equal to 5, which is given in the statement. Moreover, phi equal to 30 degree. This is also given in the statement, and here sine 30 will be equal to half, and sine square phi will be equal to 1 by 4, that is 0.25. Okay, sine 30 is equal to 0.5 and sine square 30 is equal to 0.25. H is the Planck's constant which we have taken from the table. Okay, and mass of proton is equal to, we also taken this value from table. Okay, this value from table, this value from table, this value given in the statement, this value given in the statement, and sine 30 equal to 1 by 2, sine square 30 equal to 1 by 4 equal to 0.25. Okay, E dash is equal to 2 electron volt. This is also given in the statement. Okay, kinetic energy of proton E dash is given as 2 electron volt, angle is given as 30 degree, n is given as 5, h is a Planck's constant and its value has been taken from the table. Moreover, mass of proton is also a constant and has been taken from the table. Okay, putting all these values in equation number 2, we get d square equal to this, and this implies that d square becomes equal to 1.026 into 10 raised to the power minus 20 meter square. Here, but we have used n h value of Planck's on this. MP is equal to this. Okay, then here actually in place of c square we can use 3 into 10 raised to the power 8 meter per second, and c square will be equal to 9 into 10 raised to the power 16 meter square per second square. Okay, this is quite obvious. Moreover, electron volt square will be cancelled because electron volt is this and this is electron volt, and this is square and this square will be cancelled with this. Okay, moreover, c square is in meter per second square, meter square per second square. This second square will be cancelled with this second square. Okay, and hence our result will become in meter square. Okay, so d square becomes equal to this, and hence we will take under root of both sides, and hence d will become equal to 0.026 into 10 raised to the power minus 10 meter. This implies that d equal to this. We can convert it into 10 raised to the power minus 9 because 10 raised to the power minus 9 is nano, due to which this factor will become 0.1026 into 10 raised to the power minus 9 meter equal to 0.1026 nanometer. Okay, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.